So in the last example that we looked at, we had 492 divided by 4. And in that case, we actually were able to use 100 as part of the quotient. Let's look at another example because this introduces some other things we need to think about where we're not actually going to be able to use every place value in that dividend. So we're going to say 332 divided by 4. And again, we're sticking with this idea of how many 4s does it take to compose 332. That's more of that measurement idea. And that's generally how we're thinking about it in each of these methods. Okay, so let's move to looking at our partial quotients first. And just like we did last time, we're going to start thinking about place value. So we're going to look at the 300 and ask ourselves, 4 times 100, how close to 300 is that? Well, it actually ends up being more than 300. So 4 times 100 is 400. I could list that in my table if I wanted to, but for the sake of space, I'm not going to list it. So we know we can't actually use any hundreds in our quotient. And if you're familiar with a pretty conventional way to describe long division, that's really the same thing as saying 4, how many times does 4 divide into 3? And then you move to call the 330 33. That's really the same step. It's just now we're actually using more accurate place value language. So we're not just detaching from that and thinking of these as their own digits. And we're actually calling them what they are in terms of in that dividend. This is 300. So we know that 4 times 100 is not going to work. So we have to move over to the tens place. Now you can actually describe this 2 different ways. First, we can just say 330, or we could say 33 tens. And if students need some connection to that, it's not going to be a huge issue if you briefly say, well, 4, how many times would 4 go into 33? But then coming back to make sure we're restating that as 33 tens, so they don't detach from place value. I personally like to just think of it as 330, and I know that I'm working with tens. So in my table, I'm going to list that 10 times 4 is 40. Now I know that's going to work. I could literally keep going by tens the whole way down, but the whole point of this video is to really talk about how to help kids be more efficient. But when they're first learning, if they need to pull out 10 at a time, that's a great place to start, and then they can work on collapsing those different tens into larger chunks to make the process more efficient. So I'm going to just work with the table now before I commit anything to the partial quotients. Well, if 10 works, 20 should work. That's 80. Well, now I'm starting to see that it's going to take quite a few tens here to get to something close to 330. So one thing that I like to think about is going by maybe doubling, maybe making larger jumps. We know 100 isn't going to work, so it's something less than 100. So I might actually list 40. Okay, well, I'm going to double the 20 to 40, which means I double the 80 to 160. Okay, that's getting me closer. And then I like to kind of check, well, what if I double one more time? Because obviously I need quite a bit of distance here to get to the 330. So I'm going to double the 40 to 80, which gets me to 320. Another way you can talk about that would be if 4 times 8 is 32, 4 times 80 is 320 or 32 tens. So keeping that place value, that's another way to connect to that. So now I've got 4 times 80, and then I always like to ask just one more place value question. Well, what would 4 times 90 be? And that's actually 360. That shoots us over the 330. So we're going to set the number of tens at using 80 in tens. And then again, in our area model, just like we're painting out, we're going to iterate out 4 times 80, again, not perfectly proportional, but at least suggesting it. So now I only have 12 left. And from our last example, we knew that that was 4 times 3. So I can list that here in the table. And so then to find the quotient, we found it in parts over here. We've got nothing left to as part of our dividend. So now we're going to say, okay, our quotient is going to be 83. It is helpful just because kids are eventually going to learn the standard algorithm to line up the quotient with the place value in that dividend. So the 8 tens line up with the 3 tens from 330, the 3 ones line up with the 2 ones. And now these two parts that are in our area model, I can take them and compose them together to get 83 and 332, and that gives us our final quotient. Okay, I hope this video was helpful. We're going to build more videos on taking some of these ideas and extending that to fractions and decimals, which a lot of these steps with decimals end up being very similar. But there's a couple key place value things that you have to think about when you transition to using these methods and models with decimals.